Hey everyone, welcome back to another session with OneClass. My name is Bassam, I'm an engineering graduate, and today we're going to be going through some physics questions at the high school and preliminary university level. So let's get started over here with the first question. Okay, so we're gonna look at the question and then look at the junior tutor's answer, and then we're gonna try to verify the answer and go through the correct process on how to get the solution. So this first question gives us a plot, angular displacement on the y-axis, and then time in seconds. The first question, part A, what is the angular displacement of the wheel between time equals to 5 seconds and time equals to 15 seconds? And then part B, what is the angular velocity of the wheel at 15 seconds? So we're trying to evaluate for these two components based on this plot. So going through the junior tutor solution, so we have here, we can extract the following information from the angular displacement versus time graph. So they correctly go through the first step and they look at the graph. So at time t equals to 5 seconds, they get 100 radians, and time equals 15 seconds, they get 125, and then they take the difference, get 25 radians, and then here they show that this is in the clockwise direction. And then for answer B, the angular velocity of an object is given by the rate of change in the angular displacement of the object. It is slope of the angular displacement versus time graph. So they've correctly defined the angular velocity, and they've taken the slope based on the graph, and they obtained 5 radians per second anti-clockwise. So let's go through this step by step to figure out how to go about the right process and then if this is the correct solution or not. So this is question number 1. So part A. So let's go back to the question. What is the angular displacement of the wheel between time equals to 5 seconds and time equals to 15 seconds? So displacement here, we're not looking at distance traveled, so it would be just taking the difference between those 2 points at those points in time. If it was distance traveled, then we'd have to do a different calculation, but here we're just looking at displacement. So at time equals to 5 seconds, if we look over here, at 5 seconds we have 100 radians, so we'll say, so here we'll say at theta when time is 5. So here we have theta t, and we're trying to evaluate at theta when time equals to 5, and we get 100 radians. And then here at time equals to 15, we can see that this is about 125. So 15 equals to 125 radians. So here we do final minus initial. So the final at time equals to 15 minus the initial at time equals to 5. And we have theta 15 minus theta 5 will be equal to 125 minus 100. And we end up with positive 25 radians. So to assign a clockwise or counterclockwise for this, so whenever you're looking at, let's say, a coordinate system, you always take the counterclockwise direction as positive. So we'll say counterclockwise is positive, and then clockwise direction is negative. Clockwise is negative. And this is for, that's just the standard for physics problems. So here, because we have a positive value, we'd say 25 radians counterclockwise. And that would be our answer for part A. So let's look at over here. So here they have 50 radians clockwise and 25 anti-clockwise. Interesting. The net displacement of time equals to t to 15. So I'm trying to figure out what they did here. So they initially had this angular displacement. So I believe the question was asking for angular displacement, which is correct. So here the direction of the angular displacement can be found, rotation of the wheel. The wheel rotates 50 radians clockwise from t to 5, t to 10. So angular displacement is increasing. And then angular displacement is decreasing. So since we're asked for displacement, not necessarily like the distance traveled, we'd only really care about the 2 points here. So we only care about at time equals to 15, at time equals to 5. So although this is showing an increase and a decrease, really it's only from here to here, which is an increase. And that's why you would get counterclockwise rather than clockwise. So they get the right value but the incorrect direction. All right, let's go to part B. So for part B here, so here we're looking at what is the angular velocity and we equals to 15. So at 15 we want to know the angular velocity. So we're giving an angular displacement versus time graph, so here angular velocity would be just the rate of change of this slope right here. Because we have a straight line, we can kind of just take 2 points on this line and do the rate of change. So we know that the angular velocity at times equal to 15 will equal, so we'll take rise over run. So we'll say this is the final point and this is the initial point. So at the final point we have the y-axis is 100 minus at the initial point the y-axis is 150, and then we have the x-axis here, so final point is 20 and then initial point is 10 seconds. So we just took final minus initial to do the slope, and we did essentially kind of rise over run. So here we take the y-axis, 2 values at the y-axis, and we get 100 here for this point, and then 150 here for this point, and then similarly 20 for this point, and 10 for this point for the x-axis. And we end up with negative 50 over 10, which gives us negative 5 radians per second. So let's scroll down over here. So angular velocity at 15 seconds, so they do a similar calculation, they end up with negative 5, and then they give the anti-clockwise direction for a negative. So this is kind of just switched around, so this should be anti-clockwise and this should be clockwise, because as we said, for a coordinate system, the counterclockwise direction is positive and then the clockwise direction is negative. So here we would say clockwise. So actually we would say 5 radians per second let me just erase this, write it a little clearer. So radians per second clockwise. That's our final answer for part B. So we'll write a comment here. So correct answer and process. Part A should be counterclockwise and part B should be clockwise. The directions are inverted. Okay, and we'll mark this as correct, and we'll move on to the next.